So a couple of the things that I want to share with you, I'm going to start right at the top and I'm going to discuss basically what's in there. When you have an equation that includes variables within the denominator, those are fractional equations. Okay? So for sake of argument, I'm going to just copy the one they have, and I have several more examples, a couple more anyway. Okay. I left my spaces because I'm pretty sure I'm going to have to deal with my lowest common denominator business. All right. So when you have a fractional equation, give yourself some room because you're going to have to treat it like a simple fraction equation. Okay? The first step in this argument is going to be to find the lowest common denominator, and this one's going to be x minus 2, x minus 5, and we already know that that's x minus 5, and we already know that this is a 1. Okay? So the lowest common denominator of those three pieces is x minus 2, x minus 5. Okay? So what you have to do is clear the fractions. Okay? So we're going to do x minus 2, x minus 5 over 1 for the first one, x minus 2, x minus 5 over 1. Second piece, and I didn't give myself enough room, obviously, x minus 2, x minus 5 over 1 for that last piece. Cancel where appropriate. So in this case, these cancel each other out. Leaves me 3 in the first position. Okay? Nothing cancels here because of the 1. And I'm just going to leave it just like it is for right now. And all that cancels out here is the x minus 5s, leaving me x minus 4, x minus 2. Now so far you're thinking, well, this is pretty clean. I can do this. And yeah, we're going to go ahead and keep going. We're going to make this 2x minus 4 because I distributed my 2 over my x and I distributed it over my 2. And then I'm going to FOIL this with this, just like I'm going to FOIL these two things so that I can start combining terms and coming up with scenarios. Okay? So for right now I have 3 plus 2x squared. Outside and inside, negative 10, negative 4, so negative 14x and positive 20. Hopefully I'm doing all of my arithmetic correctly. We're going to do the other side. We're going to FOIL it up. X squared, negative 2, negative 4, 6x plus 8. Okay? Combine like terms where we can and zero out the equation. Obviously this is in the book. I know you can see it for yourself. But I want you to remember why we're doing the steps we're doing. Okay, so 20 and 3, 2x squared minus 14x plus 23 equals all this, right? Let's subtract that over. Okay, you guys see what I did? Opposite sign cancels it out on the right, brings it to the left. Opposite side, cancels it out on the right, brings it to the left. Opposite sign, cancels it out on the right, brings it to the left. So now I have whatever the result is of this combination equaling 0. You guys have done all this before. $15? Okay. Looks good? Let's factor it. 5 and 3, x minus 5, x minus 3. So x minus 5 is 0, so you're apt to say, well, x equals 5. X minus 3 is 0, x equals 3. And you're probably ready to say that is your solution set. You're ready to say that is your solution set. The problem is, folks, that we cannot have a denominator that equals 0. Okay? Go back to this original piece. Okay? There's your original denominators in factored form, so it's easier to see. If my denominator includes a 5, 5 minus 5 is 0, 0 times 3, no good. You can't have 0 for a denominator. Okay, so when you find multiple solutions like this, you have to check back to make sure that both of them work. If not, the one that doesn't work, you throw out. Therefore, the answer is 3. And only 3. Okay, this step here is the critical part. Remember when we solve word problems and we come up with a negative amount of participants in a party or something like that, we throw that out? Okay, so the 3 is what is known as an extraneous root. So it appears as a result of the numbers, but it really doesn't solve the problem. Okay, so I'm kind of interpreting it for you. This is I'm sorry, up here, my 5. This is unnecessary. The 5 came up in the process, but the 5 is wrong. So when you get to a place where you are looking at your answers, first go back to where you started. Make sure that what you have will not create a denominator of 0. If it does create a denominator of 0, you throw it out. Okay? Always, always, always check. Right away I saw the 5. 5 minus 5 is 0. 0 times 2 or 3, no good. Okay? You can't have 0 in the denominator in order for this to be true. Alright? How you guys feeling so far? Takes a lot of steps. That's the worst thing about this. Okay. The rest of these examples are in my book, so you won't have them in your book, so make sure you are copying these cleanly, okay? All right. C plus 3 over 3 minus C plus space 11z plus 3 over c squared minus 9. Oh, look, difference of squares equals space 1 minus 5z over z plus 3. And that should be a z, not a 2. Okay, so I've got all kinds of stuff going on. I've got difference of squares, c plus 3, z minus 3. I've got that. Why did I write that as an x? Got z plus 3, which is shared with that. But I've got this little weird thing going on here. What do I do with this little weird thing? Well, if I throw a negative in front of this, that can reverse this. So now I have a positive z and a negative 3. Remember, by throwing a negative in front of it, it flips one of those two. It doesn't flip them both. It flips one of them. Because remember, when you divide, whatever the dividend is, the divisor is, one of them must be negative in order to create a negative result. Okay? So, greatest common factor of all that is z squared minus 9. Okay? So, we're going to throw that z squared, z plus 3, z minus 3 in front of this. We're going to put it here, z plus 3, z minus 3 over here. And remember, it's over 1. Okay? And here, z plus 3, z minus 3 over 1. Okay? So, I threw that negative in front of it. That has allowed me to convert this to z minus 3. So, cross-canceling here gives me in the first position z plus 3 squared. Okay? Z plus 3 times z plus 3. Okay? Don't forget the negative. Bring that into the scenario. Okay, that negative is still here. Next one. Everything cancels. Okay, so I have 11z plus 3. Last, the z plus 3's cancel. And you have 1 minus 5z multiplied by z minus 3. And if you want to rewrite this so that it is negative 5z plus 1, that's fine, but it doesn't matter. Okay, so remember you've got all of this, and you've got to square all that. So a squared twice the product of a and b squared. Okay, you guys remember all that? But that negative has to get included in all of these pieces because it is saying the opposite or the negative of this result. So that means the z squared becomes negative. The 6z becomes negative, and the 9 becomes negative. Okay, so now we've accommodated that negative that we threw into the mix, and we can keep going, plus 11z plus 3. Okay, I'll simplify that other side in a minute. So, negative z squared, negative 6, negative 11, negative 17z, negative 9, positive 3, negative 6. Okay, that's the simplified version of all that. Okay. Let's move on to the other side. So, f, z, o, negative 3, I, negative 5z squared last, plus 15z. Combine your z's, deal with your z squared. I'm going to go ahead and put him in his first position, descending degree of x. 15 and 1, positive 16z minus 3. If I've done all my arithmetic correctly. Can you already tell what I would exclude from the solution set just by looking at what you got as factors? Negative 3 and positive 3, right? So if somehow solving this gives me a negative 3 or a positive 3, I already know I'm wrong. Okay? I mean, I know to throw that one out. All right. I am going to move this over there because I like my squares to be positive. Ooh, that's convenient. Lovely. Okay, is everybody tracking with me so far? You okay? You guys okay back there? Okay, so I should have 4z squared here minus 7 times 14, 33z? And 6 is 17. Move that 3 over. Positive 5z, 16, negative 3, 4z squared. Somewhere in here I made a mistake, right here. Somewhere I made a mistake. Outside is 3, inside is negative 5z squared. 5 is positive 15. That's a positive z. Kind of wondering if my book made a mistake somewhere, because it's showing this differently. let's see, minus 3. Yeah, because that's not going to work. Why, yes, it will. I get 12. Oh, no, I won't. Bear with me, guys. Somewhere there's an error. Z squared plus 6 minus 6z. 11. So the negative and the negative makes that negative, and that's correct. Oh, that was a positive. Goofball. This should have stayed positive. Ugh. See, that's positive, that's positive. So negative 6 combined with a positive 11 is a positive 5z. Place I made my error right here. For whatever reason, I flipped that. So I apologize for that. Positive 5, negative 16 is in a negative 11. Now I can do something with this. I can do 4z, and it's already factored for me, so I'm cheating, plus 1, and z minus 3. Okay, all of that equals 0. Looks like there's going to be a 3 involved, isn't there? So 4z plus 1, so z is a negative 1/4, z minus 3, z is 3. Okay? Those scenarios, right away I can throw that out. Because I know 3 minus 3 will create a 0. That is your extraneous root. Not going to be necessary. The only solution that actually works is the negative 1/4. Okay? This is always the kind of mistakes that people make, including me. Somewhere along the line, you didn't add or subtract correctly, and then you get to a place where you can't solve it. Okay? Had I simply kept that as a positive, like I was supposed to, the positive combined with the negative would have been the 5 that I needed to get to that. Okay. One more. I need all the paper I can get. All the paper I can get. All right. 10 over x squared minus 4, difference of squares, that's convenient, equals 1 minus, okay, 1 over x plus 2. Well, there's the other difference of square part, right? This is x plus 2, x minus 2. Lowest common denominator of all of these things is going to be x plus 2, x minus 2. Okay? Each thing is going to get multiplied by that. Okay? And if I multiply x plus 2, x minus 2 by this one, I know it cancels out. Okay? I'll write it in there just so you don't think I screwed up somewhere. That cancels. 10 equals x plus 2, x minus 2. Minus x minus 2. Minus x minus 2. Now there's a reason why you keep this in parentheses, because this entire factor is going to be subtracted. So that negative is going to need to be distributed over both of those parts. Okay? Difference of squares here, x squared minus 4 minus x plus 2. All of that equals 10. The 4 and the 2, so x squared minus x minus 2, subtract the 10, so minus 10, how about 12? Okay, I subtracted the 10 over to here, it made that negative 2 because of the result of combining these into a 12. Subtract 10, combining those, subtract 10. So now I have 0 equals, and this is going to be negative 4 positive 3, x minus 4 positive 3x plus 3. I don't think we have any extraneous roots this time. Both of those would be okay. Neither one of those is going to create a 0 situation. So x can be 4. x can be -3. Both of those fit because neither of those causes an extraneous zeroed out mess. Okay? You're only doing 10 problems, the evens. If you get to a place where you're stuck, the first thing I recommend is going back and checking your basic arithmetic, because you saw how that totally unraveled the problem when I had an incorrect sign there. Okay? Nice and slow. The first few problems are really easy. If you look at example at number 2, greatest common factor is 4x, so that's not going to be too hard to deal with.